So we are going to be solving a combination of point loads and U.D.L in this question. So in this question, if we are finding for the shearing force around A, the shearing force at A is equals to this 1 kilonewton that is here, that is this point load at the exact edge, which is equals to 1 kilonewton minus 1 kilonewton. This is it is bending minus 1 kilonewton. Then at C here, the bending moment, the shearing force also is still 1 kilonewton, because at this point we have minus 1, which is this one. Then this one, which is the bending load, we have minus 2 times 0, because it has not moved any distance from C here. So it will eventually become minus 1 kilonewton. That is for shearing force of C. And now the shearing force at D here, the shearing force at D is equals to this one here, we have minus 1. Then this one here, the load per meter times the entire span, which is equals to minus 2, which is this load, times the distance, which is 2. So we eventually have minus 5 kilonewton for the shearing force at D. Now for the shearing force at E, the shearing force at E, we have this times the meter, and we have this here, which is equals to, we have minus 1, then minus 2 times 2. We also have another minus 1, which will be equals to minus 6 kilonewton. And the shearing force at B will still be the same thing. The shearing force at B will be equals to minus 6 kilonewton. That is for the shearing force. Now to the bending moment. The bending moment at A will be equals to, if we look at the bending moment at A, the load at point A times the distance, that is minus 1 times 0, which is equals to 0 kilonewton meter. That is the bending moment at point A. Now the bending moment at point C here, the bending moment at point C will be equals to this load here times the distance, like the distance from here to here. So we have minus 1. What is the distance from A to C? That is 1, which is equals to minus 1 kilonewton meter. And the bending moment at D will be equals to this one here times the distance from here to here. So it will be this minus 1 times, what is the distance from here to here? We have 1 plus 2, which is 3. So this 1 times 3 here, like the load here times the distance from D, that is 1 times 3. Then for this one we have minus 2 times 2. This is the shearing force. Then the distance from the centroid, which is times 2 divided by 2, which will now give us minus 1 times 3, we have minus 3. Then this will give us minus 4, which is equals to minus 7 kilonewton meter for this. Then also the shearing for the bending moment at E, the bending moment at E would be equals to 1 times the distance from E. So we have minus 1 times, what is the distance from E? 1 plus 2 plus 1 here, that is times 4. Then from C, this one here, which is minus 2 times 2, that is the shearing force. Now the distance from the half of the U.D.L here, we have 2 divided by 2 plus the remaining distance, which is 1. Then we have minus 4 minus 2 times 2, 4. 4 times 2, we have minus 4 here, times 2, which is inside bracket, which will be equals to minus 4 minus 8, which is minus 12 kilonewton meter. Minus 12 kilonewton meter. Now the bending moment at B here, the bending moment at B would be equals to 1 times the total distance from B, that is minus 1. The total distance from B here is 1 times 2, 1 plus 2, which is 3, plus 1, 4, plus 1 here, which is 5. 1 times 5 minus, now for this one here, the shearing force, which is minus 2 times 2, then the distance from half of the span, which is 2 over 2 plus 1 plus 1, that is plus 2. Then minus, we have minus this one here, which is minus 1 times the distance here, which is minus 1 times 1. If I sum it all up, I have minus 5. Here we have 4 times 3, minus 4 times 3, we have minus 12, and here we have minus 1, which is our answer will be equals to minus 18 kilonewton meter. That will be our bending moment at B. Now for the shearing force drawing and the bending moment drawing. For the drawing, so for the drawing, first of all, for the shearing force, we draw our neutral line, which is as 0. Then our shearing force at A is 1 minus 1 kilonewton. We take minus 1 here, this is 1 kilonewton. Then our shearing force at C is still 1. At first, it is still 1 here. Then our shearing force at D is minus 5. So D is somewhere like minus 5 here. We draw our diagonal line here, minus 5. So we have 5 kilonewton. That is the distance from here to here. And after that one, we also have our shearing force at E to be minus 6. So this is straight line because it's a point load. We come here, we get minus 6. And our shearing force at B is still the same thing as minus 6. So we have 6 kilonewton. And everything here is negative. So this is the shearing force diagram of this. Now to the bending moment diagram, we have what is the bending moment at A is equals to 0. So this point here, that is 0. Our bending moment at C here is, which is here, is minus 1. So something like this, minus 1. We draw our diagonal line here. Then our bending moment at D is minus 7. So minus 7 can be somewhere here. And since this is a U.D.L, we will have a parabolic curve there, like a parabolic curve there. Then our bending moment at E, is minus 12 kilonewton. So minus 12 kilonewton here. So we draw our straight line minus 12. Let me put, we have 1 kilonewton meter. Here we have 7 kilonewton meter. Here we have 12 kilonewton meter. And our bending moment at B is minus 18. So you can have something like this. Here will be 18 kilonewton meter, where everything is negative. This 12 is the distance from here to here. This one is the distance from here to here. This is the distance from here to here, like that. So this is the bending moment diagram. This is the bending moment diagram and the shear force diagram for the load right here.